Okay, can you see my presentation?
Yes.
Okay.
Yeah, perfect.
So today I'm going to present my work that is entitled Recognizing Misogynous Memes, Bias Model and Tricky Archetype. The main work focus on the field of multimodal hate speech detection. In particular, there are many ways of expressing thought and convey messages, especially in the social media environment. And one of these modalities is represented by memes. Memes are images with a text added at posteriori with the main intent of being funny or ironic. However, despite the ironic nature of the meme themselves, meme can also convey hateful messages, like the one that I reported in the slide. And those type of modality is particularly challenging because different meme can share the same image or the same text but convey a completely different message. So for instance, here we have two different memes that share the image or the text but convey a non-hateful messages. So looking at the state of the art, focusing on hateful content detection, we can identify three main fields that focus on the linguistic, on the visual, and on the multimodal aspects. From the linguistic point of view, the majority of the work try to identify hateful content, especially in tweets. And for that task, there also are many challenges. For instance, some organized challenges are Evalita or Ipereval. From the visual point of view, there isn't such task as hateful content detection, but the majority of work try to identify skin area or pornographic content. While moving on the multimodal point of view, there are some works that are somehow related to the hateful detection field that try to identify violence content. And looking at the hateful itself, there are some challenges like the hateful meme challenge and the mommy challenge that address the task of hate detection in memes. In particular, the hateful meme challenge was organized by the Facebook AI and doesn't have a specific target, but try to, in general, identify hate. And the mommy challenge at SEMEVAL try to identify hate toward a single minority that is represented by women. In my work, we addressed four research questions. The first one tried to identify which modality that compose a meme contributes more in the recognition of hateful content. So we try to understand whether the text or the image are more useful in the task of hate detection. For the second research question, we want to understand whether our model are biased and try to identify the elements that can lead the model to those unwanted behavior. With the third research question, we try to mitigate the bias that we identified. And finally, we want to understand whether there are open challenges and which are the characteristics of those memes that represent the tricky archetypes. So before I start, a quick introduction about the dataset. We used the MAMI dataset. MAMI is a multimedia automatic misogyny identification dataset proposed at SEMEVAL. It includes 10,000 memes that represent hate against women in a different way. In particular, in memes, we can convey a message of hate toward women that has different types. So for instance, shaming, stereotype, objectification, and violence. And all of those types, despite all of them are conveyed within the meme, they share different characteristics and specification. Therefore, the task of hate detection toward women is not that simple. For the first research question, we want to understand which modality contributes more. So we created 4 unimodal models. It means that all of those models try to take in input the meme looking at the single modality that composes it. So that either the text or the image. For the text, we propose this simple neural network that takes in input the text transcription the transcription of the text inside the memes. We represented it in the Latin space using the universal sentence encoder, and we define a simple neural network with only one hidden layer in order to keep a simple computational structure. But we also compare our results with the state-of-the-art text BERT. Additionally, we investigate the image via two different modalities, that is the image tag and the image caption. Image tagging and image captioning are two techniques that allow to represent the image within the meme in a textual form. In particular, with the image tagging, we achieve a list of tags, and with the image caption, we achieve a sentence that is able to describe the image. Since in the image tagging we have a list of tags, we don't have the compositionality and the structure that are typical of sentences. So since we don't need to represent those structures within the embedding, we decided to compute single embedding for each tags and perform a min operation in order to achieve a single embedding representation for the whole image. Again, the neural network is the same that we define for the text, so a simple neural network with only one hidden layer. We also define multimodal approaches that takes in input the whole image and text representation by concatenating the embedding of the two modalities. In particular, here I reported the two structure for the text and caption and for the text and tag models. As you see, the two models architecture are super similar. The only difference is again that since the tag doesn't appear in a sentence, we perform a min operation. Once we achieve the two vectors, one that is able to represent the text and the other that is representing of the image, we perform a simple concatenation. We give this as input for a simple neural network that has double the size of the previous ones, since the input embedding is achieved toward the concatenation of the two modality. We also perform our computation analyzing the state-of-the-art visual BERT. In particular, we adopted the pre-trained visual BERT released by Facebook AI for the Hateful Meme Challenge, since it was already fine-tuned on a similar data, but we added an additional fine-tuning on the MAMI dataset. Looking on the achieved results, we can see that for the unimodal point of view, the text appear to be the most informative modality and the most useful modality that contributes more in the task of misogyny detection. However, looking at the multimodal point of view, we see that we achieve higher results. So we can state that a multimodal approach is mandatory when we try to identify hate in memes. If we look deeper at our results, we can see that the proposed approach that is based on tag, the one that is highlighted in orange, achieve better results also comparing with the state-of-the-art visual BERT. Moreover, if we look deeper, we can see that all of the achieved results are characterized by high precision and low recall on one class and high recall and low precision on the other class. And this phenomenon suggests the potential presence of bias. So we continue our analysis by performing an error analysis. And in particular, here I reported 3 different memes that share different characteristics and that has been wrongly classified by the proposed model. In particular, the first 2 memes represent hate towards women using only a single modality. So for instance, looking at the first meme, if we only focus on the text, it's not going to be possible to identify misogyny. This is why the image-based model were able to correctly classify the meme, while the text-based model weren't. The opposite behavior appear in the second meme, while for the last meme, both the image and the text are needed to correctly understand the message and therefore to classify correctly the meme. This is why the last meme was wrongly classified by all the unimodal model. Additionally, we perform a word analysis, tower word cloud. Here I represent the most common word representing the lemmas of the word in the dataset. And we noticed that there are some peculiar patterns for the misclassified memes. For instance, if we look at the distribution of words within the misogynous subset of the training dataset, we find girl as one of the most present terms. However, this term is equally present in the subset of memes that were misclassified by our model. It means that our model classified those memes as misogynous even though they weren't. And this behavior can be lead to the unfair distribution of the girl term in the training dataset. A similar behavior appears for the word girlfriend, that has a high frequency in the non-misogynous subset of the training dataset and lead the model to classify the memes that contain this term as misogynous even though they aren't. This behavior suggests the presence of bias. In particular, we are talking about sample bias. Even though there aren't a specific and well-defined definition for bias, in this case, sample bias represent an unwanted behavior that the model learned due to a not proper randomization in the training data. This means that since some terms or some elements appear in the training data with an unbalanced distribution toward the different classes, the model learns to associate to the elements to the meme that contain those elements a specific class given their unfair distribution in the training data. So in order to identify those elements that can lead the model to be biased, there are some state-of-the-art metrics. So for instance, the polarized weirdness index. However, those metrics have some unwanted behaviors. For instance, they are unbounded and they doesn't properly allow a comparison within the elements. Moreover, the polarized weirdness index measures the distribution of the term in the dataset that we are using in comparison with a more general dataset, but it doesn't take into account nor the number of time a specific element appear in a sample, and moreover, it doesn't take into account the context in which a term appears. This is why we propose our metrics to identify the elements that could lead a sample to be biased. And our matrix is basically measure the difference in probability of a given element to be associated with the positive class with and without the element under analysis. It means that we expect the model to have a switch in the prediction when we remove the element that lead the model to be biased. With this metric, we are able to compute a score for each element. With element, we can consider both term and tags that represent the image, so it allows to identify multimodal elements, and we are able to associate a score to all of them in the range between 1 and -1. The higher the score, the more the term or the image tag is related to the misogyny class. The lower the score, the more it is related to the non-misogyny class. We were able to identify those, I reported here the top and the bottom term and tags that related to the misogyny and non-misogyny class. And as you can see, we have both elements that are related to the misogyny word, like this dishwasher or other terms that are super related to stereotypes. But we also have some domain sources like the motivational, identifying that some sources are more prone to share misogynistic content. We selected those as elements that could lead the model to be biased, and we are using them in the definition of a metric that is able to measure bias. In particular, the metric that we propose is composed by two subparts that are the AUC row and the AUC int that allow to measure the performance of the model both on the test set and on the synthetic set. This ensures that the model behaves properly in the presence of the candidate bias element, both when considering both the classes. When we are looking in the second part of the metric, the AUXIN, we are computing the ability of the model to perform well in the two subgroups defined by the modality that compose the meme, that are the text and the image. And with all of the AUC subpart, we guarantee that the model perform well in the presence of the candidate bias element that we identify, considering the two subclasses, so defined by the label, so misogynous and non-misogynous. With this matrix, we were able to evaluate the state-of-the-art model and also to propose a mitigation strategy based on Bayesian optimization. Bayesian optimization is a strategy that allows to identify the best subset of hyperparameter to minimize a specific value. In this case, we want to minimize the opposite of the MBA. That means that we want to maximize the performance of the model, also considering bias subsample. Bayesian optimization starts from an initial hyperparameter configuration that allows the definition of a probabilistic surrogate model that is based on Gaussian problem. Then, using an acquisition function, it identifies the next hyperparameter configuration to be evaluated. This hyperparameter configuration is used to define a new neural network on the training data, and it is evaluated to compute the metric that we want to minimize, and it continues in a cycle way. We adopted this algorithm in order to identify the best hyperparameter configuration in the training set. And I want you to notice that we also used the synthetic dataset that it was needed for computing the MBA, but we left out one part of the synthetic dataset for the final evaluation. Once the best hyperparameter configuration was estimated in the training set, that configuration is used to train another machine learning model with the same characteristics, but using the whole training dataset. The final prediction are achieved by using the left part of the synthetic dataset and the test set. So the whole performance are on unseen data. We computed the MBA, but we also identify its subpart that compose it. The achieved results show that the Bayesian optimization strategy improved the model performance both on the synthetic dataset and on the raw test set. That is the test set proposed by the challenge organizer. We can easily notice that for the visual BERT, we do not have an improvement in performance. And this is because a previously optimization process for the visual BERT model was performed by the Facebook AI team, that is the team that released the model for the Hateful Meme Challenge. It means that the same hyperparameter were already optimized for a similar task, and this Bayesian optimization process just confirm the previous hyperparameter configuration. We can see that only for the multimodal text and caption based model, we have a significant improvement in performance. However, when we look at the first two columns, we can see that also for the multimodal text and tags, we have an improvement also in the test set released by the challenge organizer. It means that this Bayesian optimization doesn't only lead the model to be less biased, but it also improves the performance on general memes. We also compare our mitigation strategy with two state-of-the-art mitigation strategy that are repair and sampling, and we outperform the results achieved toward those metrics. Finally, we perform an additional analysis in order to identify the specific archetypes that represent open challenges for misogyny detection. And we highlight those archetypes that have specific characteristics that are still open problem in the hateful detection community. For instance, we noticed that the memes that represent popular people are not correctly classified by our model, and this is because we need to introduce additional external knowledge to correctly identify and understand the conveyed message. Other archetypes, for instance, the one that represents violence, although violence is correctly identified and is a field of study in the community, is not enough to identify the presence of violence content, but we also need to understand who is performing violence against who. So we need to understand, if we want to identify misogyny, if the woman is the victim or the one that is performing violence. So to conclude, within this work, we demonstrate that a multimodal approach is mandatory to address the task of misogyny recognition. We identify a set of part of the meme themselves that can lead the model to an unwanted behavior. And we propose a mitigation strategy based on Bayesian optimization that was demonstrated to be suitable to reduce bias in controversial meme while maintaining good recognition performance. So thank you for your attention. And that's it.
Thank you, Giulia. Congratulations. Good work. Questions? I can see in the mobile there is some question.
No, there isn't any question at the moment.
One question, Giulia. Who created the data set?
Yes, we created the dataset for the VI challenge that was about misogyny recognition, and we downloaded memes from the most famous social media platform and from a website that allowed to create and share memes. In particular, we selected our meme toward a specific keyword that were able to identify thread related to misogyny.
Okay. Have you compared your metrics with other metrics?
Yes, so in the paper we propose also other metrics. For instance, the one proposed by Poletto, the index for computing the state-of-the-art, the element that can lead the bias to unwanted behavior. But we also have for measuring the bias, we only use our matrix because it's the only one that allows to compute bias from a multimodal point of view. But we evaluate it also considering possible bias elements identified with other metrics.
Thank you, Giulia. More questions?
Giulia, one question. I would like to know if you have shown your results to any kind of industry, like the media industry, or if they are showing some interest on your research?
Till now, I just limit my research in the academic field, and I didn't have any contact with the industries.
Okay, and do you think that this is going to be more interesting for social networks or other type of media?
I think that all type of media that are sharing contents can benefit by those analyses, but yes, probably social media are the most focused on this.
Okay, thank you very much. My congratulations. Very good
Thanks.
research.
Congratulations, Giulia.